done inside the box. And if you have any questions, then please let me know so we can go over how to make that so everyone's on the same page. We started this off last time with just a sketch on the top plane. And we did a rectangular sketch that is 100 by 60. And then we made that into a boss extrude. We added a 3-degree draft to that going outwards. So you can see it gets a little bit wider as it goes up. It's 40 millimeters tall. And you can see there we have the draft toggled on and we're going out. After we did the extrusion, we rounded the corners. So we added a, I think it was a 5 millimeter fillet to all 4 sides as well as the bottom face of the box. And then after the fillets, we shelled it out. We kind of talked about the shell tool and how that works. And we used a wall thickness, I think, of 2 millimeters. 2 millimeters is actually a pretty thick box. So if you want something to be reasonably rugged, that will work fine. If you're trying to do just something regular enclosure, like if you think about like a Tupperware or like a leftovers container, usually there's going to have like a 1 millimeter wall thickness because they're usually pretty thin to save material. And they don't need to really support a load, right? So 2 millimeters is actually pretty thick for just an enclosure. And then after that, we added a boss extrude that we're going to use as a mounting point for something to go inside the box. And we haven't really added any features to that, but we did cover some of the options in the extrude. And we had it come starting from the face on the inside bottom of the box. And we had to go 8 millimeters up from that. And we included the same 2-degree draft. We had that draft go inwards because we want all the surfaces to be going kind of in the same direction so we can remove this part from a mold at some point in the future when we decide to do that. So any questions on any of those steps? Does anyone need to repeat any of those or anything like that? Yeah, Martha. For the peg, on the peg, what we're doing is we're starting from the bottom surface here, and it's just blind from that surface. So this 8 millimeters. Oh, for these 15 here? Yeah, those are going from the outside of the top edge of the box. So if I look at the sketch here for this one, you can see it goes to the outside of the top edge of the box. And it's going to be 8 millimeters at the base, and it's actually going to be a little bit thinner than that as it comes up. The next thing I'm going to add to this is I'm going to add a rib. And a lot of times we use ribs to reinforce parts. So we can have something thin, but also make it stiffer by adding a rib to it. You see this very commonly in injection molded portions. Ribs can also help to use for material distribution. So it adds an extra channel that plastic or even metal, if you're doing some kind of die casting, can flow through to help you distribute material more efficiently through a part. So in this example, we want to add a rib that's going to connect our support to the side walls of the box, just like shown here. The nice thing about ribs is all we really have to do is specify where we want them to start on a plane, and then draw one side or the center of the ribs, and it'll calculate the endpoints for us. So I want to show you guys that real quick. So I'm going to have this sketch on the top surface of my support because that's where I want my ribs to start. I could have them start anywhere else I wanted to, but in this case, I want them to start there so they're all flush with the top of my circle there. So I'm going to right click on that and I'm going to sketch on that surface. And I'm going to draw a line that goes from the bottom of my rib out towards the side of the box. It doesn't actually need to go all the way. And then I'm going to do the same thing going from the side of the peg out towards the side of the box. And then once I have those two lines, you can see them there. And I can see that they are on that kind of the top of that surface. I can go to my features. I can use the rib tool. I specify how wide I want these to be. I think I want them to be 2 millimeters so they match the size of my box, but I'm just going to check and see what I use inside the walkthrough. Looks like I use 1 millimeter for the thickness of those in the actual walkthrough. So we'll use 1 millimeter and then we'll draft out. So 1 millimeter. And you can see here the rib thickness. You can make it go on one side of the lines, the middle of the lines, or the other side. It's a little bit complicated when you have a bunch of them on there as to which side gets used, but pick what you think is best. We want to draft this. I'm going to do a 3-degree outward draft. And I want outward because I want it to get wider as it goes down. So on the peg, we did an inward draft because it got narrower as it came up. And we'll be able to see that a little bit better once we generate it. So note here that the end of the rib got filled in. I didn't need to extend that rib all the way to the side, which is nice because in my drawing, that line, I don't know where it would end up intersecting this plane, right? So it's easier for me to have that line kind of end before it gets to the wall, so the tool is not confused as to where it should end. It's just to end whenever it hits a face. Does that make sense to everybody? And I can confirm that my draft is going in the correct direction because you can see that it's getting narrower as it comes up. Anyone like me to repeat that real quick? Or even repeat it real slow? Yeah, we want it to end before it gets to the sides. And I could drag this out to here, but then it gets confusing about, is that going to come out past the outside of my box? Because I don't know, the wall of my box is somewhere between this line down here and this line up here at the height that I'm drawing this line at. So I don't really know where the end of this needs to be on that surface. But I don't need it to go really very far at all because it's going to project that line out until it contacts something. That make sense? Ribs are almost entirely inside parts, but they don't have to be inside something that's totally enclosed. You can have it start like on a shelf and then go down to a lower shelf and it'll fill down below. It just need to have something below it for it to work. You can also specify ribs to go in a different direction than how you sketch them if you want to, but most of the time you want to sketch them on the plane that you want the rib to start. But if I wanted to have a rib that went kind of opposite direction because of the geometry I'm trying to get, you can do that. I'm going to add a hole to this so I can actually mount this part. I don't remember what size hole I was going to use. Metric M2 X 0.07. That X on the 0.07, that's the pitch of the thread in metric. So we're looking at an M2 hole and probably threaded using just an ANSI default. So to get that, I'm going to go into features, hole wizard. I want a metric screw. I'm going to do a tapped. And then I'm going to go to my M2 and I'm looking for an M2 X 0.7. I don't have an M2 X 0.7. Is it M4? I said M2. Oh, it must be a typo. It's M4 in the picture, which is probably correct. That should be M4. I don't know why no, it still says 2. 4. Oh, I'm not editing, that's why. That's okay. Let's do M4. M4 X 0.7. The position, I want it to be in the center of this. I'm going to highlight over the edge of my circle. Wait for that kind of center point to pop up, and then click on the center point. Then all I need to do is here specify how deep I want this to be. So I'm going to go to my options, and it looks like this. I want it to extend up to the original bottom of the part. So instead of using through all, I'm going to do up to surface, and then I'm going to click on the bottom surface of my part. And you can see that it actually ends that hole right at that position. And then I'll accept that. This one has a near side countersink. I don't know if the one inside the sketch has a near side countersink. Looks like it might. Yeah. If you don't want the near side countersink, which is this little fillet on the top, you can go into the tools for it. My SolidWorks is freezing. Let's give it a second. There it goes. And you can edit, scroll down, find the near side countersink and just toggle it off. Just like countersink is actually nice to have. It makes it a little bit easier to align the screws. So especially something like this, where if you're going to be putting a, like say a PCB, a circuit board into an enclosure, getting the screw to line up just exactly right can be difficult. So having a little bit of a countersink there can help you to line those a little more easily. Oh, and you okay back there? No? Crash? Waiting for it to reload. It's crashing on a repeating basis. Yeah. I think all the way to the front, and then yeah. Great. You're doing that already. Bad luck on computers. What am I going to do to generate this on all four corners? I'm going to mirror it, right? So I'm going to click on my boss extrude, my rib, and my hole. All those, as well as my, I can use the front plane or the right plane. Doesn't really matter which one I start with. Oh, wrong selection. I want to get all those and my right plane. And then click on the mirror. The nice thing about the mirror tool is if you have one plane and a bunch of features selected, it's going to automatically know which one to use as the mirror plane. So I'm going to accept that. If that didn't work for some reason, I'd try using a geometry pattern, just as a note. So if you try and mirror something that doesn't work, try mirroring it as a geometry pattern. It should work fine. I'm going to mirror the mirror to get the other side. And now I've got a nice box set up right there. Good. All right. I want to show how to use the mounting boss tool in case you do end up in a situation where you're designing something like this and you want to expedite the process a little bit. It's pretty easy to use. All we have to do is specify the size of the boss we want to use and the locations. So what I'm going to do is I'm going to suppress everything after my shell. And then I'm going to do a new sketch on this bottom face. Let me see that sketch there. And then on that sketch, I'm going to define 4 points. 1, 2, 3, 4. I'm going to make all those points at 15mm distances from the sides. And you may be thinking, can't you just do that and mirror it? Yeah, I can. But the way that this tool works, I specify the parameters that I want for each of the mounting points. And then I specify, oh, that's not 15, the parameters that I want. So it's pretty easy for me to generate a lot of different mounting points using this tool. And hopefully it makes sense to you all that if I was doing this for real, probably I wouldn't want all these positions to be mirrored exactly. I would probably want specific positions for each of the mounting points. That would be a function of what I'm putting in place. And so specifying the locations like this makes it a little bit easier for me to scale this to something else in the future. I've got 4 points. All of them are 15mm from the sides. If you want to use something besides 15mm from the sides, you know, as long as it's reasonable and close to what you have here, it'll work out okay. If you get it too close to the middle, when we shrink this later, that'll be a problem, but don't worry about that right now. Everybody good? Everybody will get, maybe except Owen, everyone will get the 4 points on the sketch? All right. So this tool, if you don't know where to find something, again, I suggest using the search command. So if I search for mounting boss, I can show that right there. I can also, I should be able to just click on the little icon and it'll show me where to find that tool. So I'm not using my mouse right now. I just clicked on the little eye and then I waited for the computer to say, hey, it's over here. I like the way too that if you like don't click on it right away, you just wait. It's just a little arrow. I'm gonna do that one more time so you can all see it. I searched for mounting boss in this tooltip, and then I clicked on the eye, and then I didn't touch anything. I'm not touching anything. And it just highlights it. It's like, it's right there. Now you don't have to actually search for it. You can just click on it from the search and it'll open the tool for you, which most of the time, if I have something that's not inside my default bar here, I'm not going to bother finding tools for it. I'm just going to do search. There it is. Click on it and I've got the tool. All right. So here's the different options here. So we have hardware boss, pin boss. We can have a head or a thread. It better matches what we had before if we use a threaded boss in this case. And my positions, what I want is I want the points on my sketches here. Did I use a sketch pattern on this? Maybe I use control. No. Let me check my notes. Maybe I used a sketch pattern. I did do a sketch pattern. Okay, never mind. I'm just going to do one and then I'm going to pattern it. I think I just did that to show you guys how it was. So that gives me the position of the first one. I don't like them having this arbitrary orientation. So I almost always specify the direction of it. And you can use, I think any face will work for this. Ooh, that's not good. We need a flat face. Where's my alignment? Oh, here are the fins. There you go. So the orientation, this is the position. This is the orientation of the actual mounting hardware. Then I scrolled down to the fins and I made them align with this edge. And that just keeps them nice and square. You notice you can change the number of fins here if you want a stronger boss or a weaker boss. It's up to you. And again, depends on how much force and specifically kind of lateral loads or bending moments are going to be applied to that, will determine how thick and beefy you want the fins to be relative to the main post. Now here we have the boss height. I actually want this to be 8. And then if I want to change the other values, I can modify them as much as I want to, or as little as I want to. They need to be based off of the height. So if you go too far off, it's going to complain at you. So let me do this whole thing one more time. So I went to the mounting boss tool. The position, I picked on this face or the point. The alignment outwards is normal to whatever face you selected. And then the fins, if I scroll down to the fins, I can click on the direction arrow there. And then I use this top edge to align the first fin. You'll notice that we'll always have one fin aligned with that line if I do that. Parallel to, actually, it's parallel to that line. And the rest of them are just equally spaced. You notice this equally spaced is kind of hard checked on. I can't uncheck it. Or it's probably good. I thought there was an option here to specify the screw size. No, I don't want pin. I want it to be threaded. The E is the actual hole size in the pin. And right now it's 2.3. So that's all the parameters. You can save these out. I don't know why they don't have defaults for different size screws. They probably should. Doesn't matter that much though. I think in the sketch I just use the default. Yeah, I just use the default sizes. So I just use a hardware boss of the default size. What did I click? I clicked on something I wasn't supposed to. I probably changed one of the sizes of the fins or something. I'll just hit cancel. I'll go back in, I'll do it one more time, and I'll leave all this stuff default. Go. There's one. And then what I'm going to do is I'm going to pattern this using a sketch pattern on the pattern. Oh, I didn't actually change the size of the face. You make that 10 probably. I think it has to be bigger than this. Yeah. I actually want to drive this sketch pattern from my sketch that I had before with my points and accept it. And I'll do a geometry pattern. The geometry or the not the geometry pattern, the sketch driven pattern is nice whenever you want to have like a lot of something and they're not just equally spaced. So in this case, they are equally spaced, but I can move the position of any of those locations very easily now inside my sketch. So if I decided that I did want one of these to be like 18 off the side, so they're not symmetric, it updates very easily. So just knowing some more tools. Yeah. On. Oh, yeah, so whenever you get an error doing a pattern, your first check should be try doing it as a geometry pattern. And most of the time that'll resolve your errors. Okay, let's talk about design tables. So in this case, I've got two different configurations of a box. I have one using the mounting pins and one using some customized holes. And so what I want to do is I want to make a design table that lets me toggle between those values as well as the size of the box based off of the length and the width. So one of the things that's helpful to keep track of what those different things are is to name your dimensions and your features. So what I'm going to do here is I'm going to go into my sketch and I'm going to edit sketch 1. And where it says 100, I can click on that. And you see here is the D1 at sketch 1. I can change this to width. Now this dimension has the name width, and I know that that's going to be the width of the box. I can do the same thing on this one. I can make this to, I'm going to call it, it's not height. Maybe I'll make that length. I probably should have made it length and width, but whatever. Flip them if you want. I can do the same thing for my boss extrude. This is D1 at boss extrude. The way I got that out is I double clicked on boss extrude. You can see the height of the extrude here on the right. If I double click on the height, it brings up the dimension text and I can change this to whatever I want. So I can make this height. So now I have a length, width, and height. And you can do that for as many or as few features as you'd like. I'm sorry, the shell, double click on the shell, click on the 2. I can make this thickness, whatever I like. Now this is different from a global variable because I'm just naming a specific dimension. And you can call named dimensions in functions. So if I want to, I can make the length a function of the width by just saying equals to width at D1 or width at sketch 1 multiply times by whatever I want. And that'll go into the equation just like global variables. But really, this is just acknowledging what the different things inside the sketch are. And I can name the features themselves as well. So I can make this, main extrude. Add in some rounds. I don't know. Whatever you want. Doesn't really matter. The important thing there is that adding the names makes it easier for you and your team members to identify what those features are doing inside your design. So as you get more and more complicated designs, you can find these things with some reasonable amount of repeatability. And in our design table here, it helps because I don't get to see what all those things are when I'm making the table. Okay. So let's try making a design table. I'm going to go into design table. Again, it's insert tables, design table. I also, I can go in here and do design table. Or I can go to insert tables, design table. Either way. So if you remember where design table is, you can pull it out of the menus. If you don't remember where it is, just search for it from the command search. As long as you know the name of it, you're good. You have options here. I can make a blank design table and then add things to it. I can auto create it from things that exist inside the sketch, or I can load it in from a file. Loading it in from a file works like the text file that we used before, although it uses a CSV, a comma separated value format, rather than just a raw text file. And then you can say, do you want to allow model edits to update design table, or do you want to block it? Do you want it to be one-way or two-way? I usually leave my design tables as two-way, so that way you can make changes more easily inside SolidWorks. So I'm going to start with auto create. Click on the green check mark. It's going to ask me, what do I want to include inside my design table? And I want the width, the length, the height, I guess the thickness too. I feel like I always get a scam call on this class. It's so weird. And then I also want to include the mounting boss. What's that? The thickness of the shell, yeah. I also want to include some of these features, although I think I maybe add those later. Let me check my worksheet here. Yeah, so I add those later. So I'm just going to add the dimensions in, and then I'm going to add the features in after the fact, just because it's easier to do it that way, I think. So I'm going to add these for width, depth, height, and thickness. Click OK. You see it pulls those into the design table. And then I want to add my box extrude, rib, tapped hole, mirror as additional features inside my design table. Let me make this a little bit bigger so we can see it a little better. So to add those, all I'm going to do is have the design table open, and I'm going to double click them, and it's going to add them to that list. So I'm going to click on box extrude. You see it added it to it, rib, tapped hole, mirror. And can I zoom in on this? I don't know if you guys can read that or not. I'm going to use the magnifier to zoom in on it. So you can see there's the default, there's the width, there's the length, the height, the thickness, and then these are dollar state at box extrude, and the default here is suppressed. So in the design table, this is going to qualify as being not showing up in the default configuration. Okay, I want to zoom in so you can see that a little bit clearer. Close the zoom tool. And then I'll also add my mounting boss and my sketch pattern to the design table as well. You can see those listed as unsuppressed. Now, suppressed, this is something that's kind of confusing to me. Suppressed is 1 and unsuppressed is 0. So if you want to make a shorthand for this, you can also use S for suppressed and U for unsuppressed. But if you want to drive it off of Boolean math, zeros and ones work better. So you can actually make functions inside the design table. Just make sure that you remember that 1 is unsuppressed and 0 is suppressed, which doesn't make sense to me because you would think that it being on would be 1, which is a more common convention, right? So it's just a little bit confusing. What I want to do here is I'm going to use the design table to define a couple of different configurations of the box. So I'm going to make a big box, double clicking on here. And I want a big box with the, what are we called? Custom mounts versus the mounting hole. So I have big mounts, small mounts, big custom, small custom. So big mounts, Wait for it to respond. I'm tabbing back and forth. It doesn't like it. Big mounts, small mounts. There's probably also a way, big, to change the font on here in the options somewhere. Small. The big ones, I'm going to make the 100 into 120. The small ones, I'm going to make the 100 into 80. Yeah, let me try to use the magnifier again. I'm going to add 20 to the big ones on here as well. So 80. I'll subtract 20 on this, so 40. I'm going to leave the height the same. And the thickness I'll say the same too. Just enough so you guys can see the difference here. And then these ones, I want the same values. So I'm just going to copy it, paste it. Kind of the same thing across here. Suppressed is 1. So 1, 1, 1, 1, 1, 1, 1. Unsuppressed is 0. I'm going to copy that, paste it in. And then these ones I want to be opposite. I want my custom ones to be unsuppressed and the mounting boss ones to be suppressed. If you can't see that inside here, I don't know what I'm doing because I can't see. Hopefully I didn't break something. Oh, I closed the design table. There you go, it's still saved. Okay. Uh-oh, it didn't save it. Ah, no, why did you not save? Big, M, small, M, big, C, small, C. I should have probably read that tooltip. You got a question? So if you wanted to add like another dimension to this, you click on what the thing you want to add with the design table open, and it should add it. Double click it. I'm just putting in the same values as I had before. When I exit this, it should ask me if I want to add the new configurations, and I should just say yes. I don't know if I accidentally said no last time. Check. Configurations were added. Huzzah. Now I should be able to click on any of these configurations, and it should automatically update all the values based off what I put in the design table. Is that? Yeah, it should be the same as in the worksheet. It doesn't like my mirrored features in my. For some reason, my my line here on my rib. Ooh, my endpoints didn't work out. I'm going to try and fix that by putting my lines so they end. How can I move that? Oh, I'm editing the rib and not the sketch for the rib. I'm actually going to move these lines so the endpoints are on this inside point, just short of the import. So there's actually just hovering above that bottom line. There we go. And I should be able to still toggle between all these different features. So that make sense? And if I want to edit this table, what I'm going to do is I'm going to go from my main part over to my configurations, right click on it, and then do edit table. Then I can go through and I can add or remove things to that configuration. Following configuration parameters have been added since your model has last edited the table. I didn't actually add anything there. And then once I'm done with it, I can click on the green check mark. And if you've added more configurations, it will add those configurations to the list and update what you said you want to update. You got corrupted? Your design. Oh, okay.
Yeah, no, not at all. But no, man.
You just need to have write permission to the folder where it's making the design table. And if you open the design table in a separate program, while you have it open in SolidWorks, that can cause issues. Although most of the time it should work. Windows doesn't like having multiple programs write to the same file at the same time. So I'm not sure how tolerant that is to different errors. I do want to do a quick overview on the derived parts. So what I'm gonna do is I'm gonna do a new part. And you can make this even if your configurations didn't work, but it's more fun with configurations to work. Click on new part, click OK. What I'm gonna do is I'm gonna actually drag in my part that I just made. Oh, I didn't, where did I save it? Oh, I just desktop. Oh, I just have it saved as part 2. I'm not following my own advice. I didn't save this to like a specific folder on my desktop. Oh, week 2 box, yeah, box, okay. Oh, it's on my extra S drive though. Oh, that maybe is not smart. Yeah, I want to save the spreadsheet and the part. Why is it opening it? No, that's fine. File, save as. Okay, there we go. Box. So I should have it on my S drive. I'm going to navigate to the S drive on my computer. And I'm going to drag my box into a part, almost like I was making an assembly. And it says, are you trying to make a derived part? I'm going to say yes. And then I don't want to click anywhere on here because just like in the assembly, I don't want its position to be arbitrary. I want it to be aligned with the origin. So I'm just going to click on OK. And now what I have here is I have this part in my new part. And it has its own body. What I want to do is I want to make a lid that fits my box perfectly, regardless of the size of the box. That make sense? How did I add this to the part? So I'm going to make a new part. From this view where I have a blank part, all I'm doing is I'm dragging my box part into the workspace. It's going to ask me, am I trying to make a derived part? And I'm going to say yes. And then after I have that, I'm going to click on the green check mark. So that way I'm putting my new part origin and my derived part origin at the same spot. So my origin is there at the middle of the bottom of the box. Now what I'm going to do is I'm going to use this to draw the parameters that I want to use for my lid. So I'm going to go to the top plane on my box and I'm going to sketch. And I'm going to convert the entities of the top of the box. See that? So now I've got a sketch that is exactly the same size as the top of my box. And I'm going to extrude that out. And I'll make it, let's make it like 4 millimeters tall. And I'll add a draft of 2 degrees to it, even though you won't be able to see that very well. That's a pretty beefy lid. Oh, wait. On this extrude, I'm actually not going to merge the result. This is maybe the first time you see me not use that tool. I want to not merge that. So this is going to be a separate solid body for the lid than for the box. Now what I'm going to do is I'm going to go back to, wait for SolidWorks to respond again. I'm going to do another extrusion that comes down from my lid that's just a little bit smaller than the inside of my box. So I'm going to go back onto the top of my box. I'm just going to hide this for a second so I can see it a little better. I'm going to sketch on that face. I'm going to offset from the perimeter of the inside of my box. I'm just going around selecting all the edges. I could probably do select chain. It would be a little bit faster because I only have 2 of them. I'll do a 1 millimeter offset into my box. Everybody see that? And then I'm going to extrude that down into the box. And again, I'm going to use the same 2-degree draft. And this one I can merge with the top. And so when I show this one, that I did 2 millimeters down into it. That's probably too much. I just 4. Let's just do 2. I don't like how big this box is. I'm going to make it 2 as well. If you go through the workout, I actually make this lid a little bit more complicated. But I'm just making it a little bit quicker this time. So there's my lid. Now what I can do is I can actually delete this solid body. And I did that by clicking on delete on the keyboard. Although it's important to note, when you delete a solid body in SolidWorks, it doesn't actually delete it. Instead, what it does is it makes a feature that removes the body from the model tree. And so you'll note that I have this delete keep body. I can suppress that just like I did all my other features. And then these other 2 I want to merge together. So I'm going to click on these 2 and I'm going to click on combine. And that's going to make them 1 by adding them together. So now I've got 1 solid body. That's the lid of my box. Yeah, so I unclicked the merge so that when I made the lid, I could delete the actual box itself and just have the lid. But the lid, since the box is still kind of there, it's just suppressed. Any changes I make to the box will get updated in the lid. So now if I want to change this, all I have to do is to change the configuration of the box inside this part. So I can configure this feature and I can say I want this to be the lid for a medium box. And it automatically updates. Now, they are separate. So the configuration of the box inside this part is not linked to the configuration of the box in its own part. So I can actually have a lid and a box that have different configurations, even though they're the same set of configurations in both places, which is good for some things and not good for others. If I make an assembly, I'm going to go back to my box. I'm making an assembly from this part. Wait a second for it to load. I'll load in the box. I need to save my lid. I'm going to save this as lid, not load, lid. Then I can go back to my assembly and I can insert the lid. When you use that check mark, it fixes them by default. So I'm going to float the lid. And then you can note here that my box here configuration, since this is the large one and this is the small one, they're not the same size. But if I edit this feature, there should be configure feature on here somewhere. Let me go to my lid. I'm just going to inherit the features from the box itself. So configure, I'll make this big. Not Biggington, come on. I guess it can be Biggington, fine. And then since the internal features don't really matter, I'm just going to use big M and small c. And now I have two configurations inside my lid that are based off the configurations of the parts in my box. So now in my assembly, I can configure that more easily by just toggling it to small. And again, here's my box. I can have it be whatever I want. So they align or don't align based off the sizes of the features. Right? And if you were doing gears, you can kind of see how we could extract this back to the last lesson. I could have one gear part with a configuration based off the number of teeth. I can make a design table that pulled in my global variable for the number of teeth. And then I could swap the number of teeth just by doing a little drop-down menu, right? And so you can use design tables and global variables in conjunction. If you've got both of those linked out to exterior files, you're getting a little dicey in terms of making sure all your files are working together. But you can see how those kind of work or don't work to get different configurations out. Questions on that? All right, that's it for today. Your deliverable for this week is going to be the box, the lid, and the assembly file. And I should be able to configure both the box and the lid to be big, small, with the mounting holes or the custom holes, the default kind of the SolidWorks mounting configurations, or the one that we use with the lid without the parts breaking. They don't need to stay in alignment. So it's okay if the big lid doesn't fit on the small box or the small lid doesn't fit on the big box. But they should update without causing issues. Sound good? All right. And I will see you guys all on Friday. If you haven't started working on your first project for the Rube Goldberg, so thinking about the parts you want to make for that, I would expect that you would all have at least preliminary drafts of the parts for that project started by kind of end of the day on Friday. So if you don't have an idea of what you're doing for that, get that figured out sooner than later. That first project is going to be due on the 16th, which is not next week, but the week after next week. So it's due on, I don't know, this date. So we're at the 31st. We have next week. We're going to be covering advanced mates and motion studies in class next week. So if you have the parts that you want to use for your video or for your assembly ready for the end of next week's class, then you'll be set. You can get that working in on Friday for next week. That makes sense to everybody? I'm hoping it does. Did I publish the Dropbox for this week yet?
So in the assembly, you just want one configuration.
So the configurations are saved inside the parts. So I should be able to swap the configurations in the assembly to see that it makes all of the different configurations. I guess you need to submit the design table file too if you've exported that to Excel. As long as it lets you change the configurations, it should be fine. Yeah. You just can't edit your design table anymore, right? Yeah. I'll let you know if I download it and it doesn't open or something. It's weird that yeah, if it's corrupt, you wouldn't think it would work inside SolidWorks either, but maybe it's just an Excel thing. It is worth noting that SolidWorks does load Excel to run the table inside SolidWorks. So, all right, see Evan, you'll note that when I double click on the design table, I go to one of the parts, and I do edit this, not agent feature, edit table, I actually get Excel tabs like in SolidWorks, which is kind of creepy. Like I have, this is Excel, right? It's not actually SolidWorks anymore. which if I go to view, yeah, it's Excel except for I can't zoom apparently. Like the zoom option is gone. It's grayed out. I don't know how to fix that. Can I control plus maybe? Nope, that's insert cells. I don't know. I'm sure there's a way of changing the view on this. I just don't know where it is.